like to do next is I'd like to have a little discussion on virtualization with that PHP project that's due on Saturday, right? So you guys have never used VMware virtualization, nothing at all?
I've used
VMware VirtualBox.
Yes, sir.
Use VirtualBox. So VMware is one of those industry standards. A lot of companies use it. There's a couple big, what we call hypervisors out there, and that's what these things are. So how's that possible? I just pulled that out. Literally, I just got that out of the cabinet. All dried up. So we have these things called hypervisors. And there's some big standards out there. VMware, ESXi. We're going to be working with Workstation, because that's what we have available as individuals. ESXi, this is for enterprise. Another big one out there is Microsoft Hyper-V. You have another one out there called Zen. And there's some other ones that are out there, such as VirtualBox. And by the way, don't discount VirtualBox. Just because it's free doesn't mean that it's not powerful. And it has a lot of very powerful things that are going on. There's two different types of hypervisors. There's a stage 1 and a stage 2. Stage 1 is what we refer to as bare metal. And stage 2 is you have to have a host operating system. All right? So we're going to use a stage 2 with VMware Workstation. So we're going to have a host operating system, and then we're going to have our guests running inside of that host operating system. All right? On a stage 1, even though it says bare metal, there is a very, very teeny tiny kernel that is in place, but they still consider it bare metal. There has to be some type of a middleware in between the hardware and the guest operating systems. All right? So in general, as far as the layers go, you have guest operating systems, and then you have some type of a operating system layer. And again, it could be that stage 1 or stage 2. The stage 1 is just a very tiny kernel. I'm talking a couple hundred kilobytes. It's a very, very small kernel. It's a Linux kernel that they put in place. And then that facilitates and communicates with our hardware. Specifically, it can communicate directly with RAM and the CPU. Directly. It has direct hooks into the RAM and into the CPU. And this is virtualization. All right? The other, what came before all this is what we called emulation. Emulation was where we took a guest operating system and it was running on that OS layer, but it was unable to directly communicate with the CPU and the RAM. The CPU and the RAM and everything else were emulated with software. So we had to have hardware that was powerful enough to emulate the hardware that the operating system used to run on. So I'll give you an example. You guys like games. Have you ever played with like a Nintendo 64 emulator? Have you ever downloaded one of those? Or a Nintendo emulator in general, or a PlayStation emulator, or Commodore 64 emulator? So the hardware that we have today is powerful enough to be able to emulate with software the old hardware of those systems. So a Nintendo 64 emulator It's actually the architecture, the hardware architecture, being run in software by the operating system. Does that make sense? With this, it's direct hooks straight to the CPU. Intel and AMD have this feature. Intel calls it VT, virtualized technology, and they have a whole bunch of different layers with it now, right? And AMD just calls it AMDV for virtualization. That's the core technologies for it. And it was explicitly developed for this reason. Developers, and what we refer to today as DevOps guys or systems analysts, they would look at their server rooms. Let's say that their server room only had 4 servers in it. Not true, but before virtualization existed, they would look at their server rooms and they would look at the utilization of the resources on the machines. And they would see that the overall average utilization hovered at 20%. All right? So we're talking about back in the late 80s, early 90s, people started noticing this. As the World Wide Web geared up in the mid-90s, they continued to notice this underutilization of the hardware that they had. All right? There's a lot of things that fix this. For example, websites, when we first had our very basic web servers, you could only host one website per physical machine. Apache came along, with the Apache Foundation came along and said, this is crazy. Let's have virtual servers. So now we can host multiple servers, multiple websites on one physical server. But we still noticed that the different machines we had set up were only doing 20% utilization. Intel took note of this, AMD took note of this, and they said, we think we can do better. So they came up with virtualization. And what it enables us to do is run multiple guest operating systems on one physical host. So now, instead of having 4 machines to take care of, we have 1 machine to take care of, 1 physical machine. So we go from 4 to 1. And now, those same 4 machines, still running at 20%, on that host now is actually running at 80%. Does that make sense? So now we're using 80% of the resources of a physical machine. In addition, less machines, less what? Less maintenance? Less what else?
Costs.
What other costs though? You're absolutely right. What are the other costs?
Operating costs.
Operating costs, somebody coming in to maintain it. So not only physical maintenance, because 4 machines, that means now quadruple the amount of things that could break, right? But the maintenance of the person, 4 machines, now you gotta have 4 people to maintain those 4 machines with different operating systems and so on and so forth. But what are some of the other cost savings?
Buying equipment.
Okay, we got the equipment covered, but what else? What do computers do? What do they give off? A lot of what? Heat. So if we've got a lot of heat, that means that they're consuming a lot of power. So now I've gone from 4 machines to 1 machine. Now granted, this 1 machine probably consumes more than any 1 machine here, but it definitely doesn't consume more than 4, right? But if we're throwing off more heat, now we have to spend more money on what? What is it? Ventilation, air conditioning, right? Is that making sense? All this kind of playing together. So this is pretty much a win-win. Are there cons with this solution? Are there bad things with moving from that to this? Is there bad things that happen now? I mean, all we've done is talked about all the good, right? One machine instead of 4, 80% utilization, less power, don't need as much air conditioning, don't need as much maintenance. There's got to be some bad here somewhere, right? You guys heard of meltdown?
So here, since we have one physical machine running, like for instances, so I believe if someone is able to get into the Hyper-V of just the physical machine, is able to get into all other instances.
So if you've read about meltdown and some of the other things that have happened to all the processors since 1995, there is a theoretical way that because all of these machines share the same physical CPUs, that malicious software could grab information from one guest and send it to the other guest. Purely theoretical. Intel and AMD and ARM are all fixing it. It's going to take years to work it out. Years. This just happened over the spring. You guys do read tech news all the time, right? Do you remember Meltdown and all that?
No.
It was about the speculative branching. When it's trying to guess what it's going to do next, found out that those messages could be intercepted. They were completely sent unencrypted in the CPU. So that means if something else is running on the CPU and knows that and knows where to look for it, they can pick off that information. Yeah. So that is a bad thing. Another bad thing is, what if we misjudge this? Right? We're running at 80%, which is about the maximum we would want to run this, because what happens if this one goes to 25%, we can still have the resources. That one goes back down to 20, that one goes to 30, still have the resources. What happens if all of them go to 30%? That adds up to more than 80%. That makes sense? So what happens is all the guests start slowing down. So we have to be very cognizant of balancing what is on our host now. Now VMware can do a really good job of rebalancing that for us, but we still have to be aware of what is the overall capacity of my cluster, right? What is that overall capacity? Now, in a enterprise level setting like the university, they've taken this to the next level. And we use ESXi here on campus, VMware's ESXi. And up in Lowndes Hall, and I'll take you back in our little server room back here and I'll show you a similar setup. Up in Lowndes Hall, we have now 5 physical VMware servers. These are 4P16C with 256 gigabytes or more of RAM. 4P, 4 processors, 16C, 16 cores per processor. Each one of these. No hard drives. All right. All of these connect out to what we refer to as a SAN. What's a SAN? Charles? What's a SAN? It's Computer Science 101, man. What's a SAN? You got a computer in front of you? Quick, look it up. I don't know. I'll look it up. Terry, you got it?
Is something area network.
Yeah, good job.
SAN is.
Why you keep logging yourself out, man?
So I know.
You got the area network.
Yeah, just like LAN.
Well, LAN is a local area network. This isn't a local area network. This is a SAN.
Storage area network.
Mm-hmm.
Yeah, I remember that.
All right. So these five physical machines have a 10 gig fiber link to the SAN, the storage area network. This is just a big RAID array that has 50 terabytes of hard drives in it, and then it has about 2 terabytes of solid state drives for cache. Not cache memory, just cache for the hard drives. And what it'll do is it'll speculate what the user is going to look at next and pull it into that cache so it can be pulled off even faster. And then if the hard drives can't keep up, it'll store it on SSD cache until the hard drives can keep up. It allows for a very fast interaction with our servers over here. All right. Now, one of the neat things is with these 5 physical servers, there are about 160 instances of things running. Now, when I say instances, what I'm really talking about is 160 guests. That's it, like having 160 physical machines running inside of those 5 machines. So next time you go to www.frostburg.edu, you're hitting one of those instances. Next time you go to pause, you're hitting a couple of those instances. Because the front end is an instance, the database actually has a couple instances, right? All the other things are running in there. Your DNS is in there. DHCP server is in there. Your Active Directory stuff for your credentials, your authentication, certificate authority. All of those are individual servers, operating systems running inside of it. All right? You're getting a lot of theory, a lot of concept here. Because I want you to understand, when you go to work in an enterprise environment, this is how things are kind of set up on the back end for your web development. All right? You need to embrace this. It's good knowledge, because if you can understand virtualization, it's going to help you be able to simulate something like Docker. All right? Docker functions very much the same way. It's a virtualized micro instance. You develop your code, you package it into a Docker, a container, you ship it off, the other DevOps place just plugs it right in, and boom, you're up and running. All right? So you've got to have this idea, this concept of what's going on. Now, to take all this to the next level, we have 5 machines all controlled by ESXi. All right? Let's say that we keep every single machine running at 50%. All right? If I got every machine running at 50%, and I got to do maintenance, I have the flexibility to be able to redistribute all of the instances from the physical machine to the other machines. This is where it starts making sense that there are no hard drives in here. If there's no hard drives in here, I don't have to worry about physically moving something from here to here. I don't have to worry about copying something over because it's all over on the SAN. Does that make sense? So this is what you do. You go into ESXi and you say, I got to do maintenance on server 3. So this is server 3. Please shut down and redistribute the instances that are on there to the other ones. So now what it'll do is it'll knock each one of these up to, what, about 62.5%.
So is this something like sharing the loads?
That's exactly what it's doing. It'll completely, dynamically, transparently move those instances and give them control to the other servers. Because remember, all we have is symbolic links over here. So it just says, okay, this is what you need to take care of here. You need to take care of this one. You need to take care of this one. You need to take care of this one. All right, everything's done. We'll shut this guy down. I go in, I put more RAM in, I fix the fan, whatever needs to be fixed.
Wow.
Close it up, turn it back on. I hear a ding on my phone. We noticed that server 3 came back up. Would you like to rebalance the cluster? I would. Transparently, dynamically,
Drop the loads.
it moves the responsibility, that extra responsibility, back to here, and everybody else goes back to 50%. Now remember, there's a maximum here. In this scenario, you can only really have one down at a time or one failure. If you go to 2, you're stretching your limits. You go to 3, things are going to slow down. Performance overall is going to slow down. So that's why we have redundancy built in there, right? So that we can handle one of them going down for maintenance or whatever.
Can I ask a quick question?
Yeah.
In a situation where you have maybe you want to do like a maintenance on one of the physical machine,
Sure.
and you have the load being shared among other
By the
physical
other
machines.
ones, yeah.
So I want to like kind of relate that to a website. Is that like the reason why sometimes when you're trying to access a website it runs slow?
You got it. You got it. Now there are other factors there too. There could be something wrong with the network or something like that. But it could be wherever the website is hosted, it's not balanced appropriately. Or maybe they are doing maintenance. Or maybe they're getting bigger hits or something like that. I don't know. But there's a distinct possibility that something could be down for maintenance, which makes the website overall go slower. Make sense? This is the foundation of cloud computing. This is it. You're looking at it. It's the very foundation of cloud computing. Anybody know who the leader in cloud computing is on the planet?
AWS.
Who is it?
AWS.
Which is owned by who?
Amazon Web Services.
Good job, man. I thought you had a degree in computer science. He's kicking your butt, man. Where's that come from? Where did Amazon, how did they become the global leader in cloud computing? What did they originally do? What did they originally set out to make money with? It didn't have to be the original thing. What were they originally trying to do? Sell stuff. Right?
Oh.
Sell stuff. Originally it was books. I don't know if you know that. If you go way back,
Amazon
it was set up as just books. That's all they did. This multi-billionaire out of his garage said, I think I'll start selling books and I'll call it Amazon.
So
And then they started, now hold on. Then they started selling stuff, right? Then then this internet thing kind of really started to take off, and e-commerce kind of got real. So if we look at our sales, maybe we're looking at it as simultaneous hits per second, right? Because that's what we're worried about. If somebody hits our website, can we handle it? Can we handle the load, right? So we got 12 months. January, February, March, April, May, June, July, August, September, October, November, December, right? So let's say we're at 0 to 30,000 simultaneous hits per second. Per second.
That's a lot.
It's a lot.
Different location.
January, February, March, April, May, June, July. This is in the beginning. August, September, October. It's hitting like 10,000 simultaneous hits. What happens around November?
Increase.
Why?
Because of this season.
Because of what season? The holiday season, Christmas, all of those, right? Everybody starts buying stuff.
Mm-hmm.
They're buying. I mean, heck, they did Cyber Monday, right? It kind of came from them, right? It goes up and up and up, and now we're hitting like 30,000 simultaneous hits or more.
Jumps over generally.
Now, what happens right here? When this big e-commerce thing really started hitting, right in that area, Black Friday, Cyber Monday, Amazon would crash. They didn't have the capacity to be able to handle the customers. If you don't have the capacity to handle the customer's requests, what happens?
Server will go down. The website will go down.
No. Stop thinking technically. If you can't give a customer service, you can't do what? If you walk in to purchase something in a store and the store is closed, you can't.
You cannot find. You
can't buy anything. If you can't buy anything, the store can't. They can't sell you anything. They can't make money. So if they crash, they're losing hundreds of thousands of dollars per minute.
Did it actually happen?
Oh yeah. This is the history of where AWS came from. So, crap. We lost a lot of money. Buy more servers.
Yes.
Great. Next year it goes up a little bit. We're cruising along. Higher. We hit here. Whoa, yes, except for our servers crashed again. This happened like 3 years in a row, man. What do we do? If I can't serve my customer, I can't sell anything. If I can't sell anything, I'm not making money.
Lose money.
What do?
Increase the servers.
Buy more servers. Buy more bandwidth. Great. Next year it's even better. Oh no, it still crashed a little bit. What do?
Increase the bandwidth.
Here we go.
Increase the servers. Now
eventually we solve the problem. Eventually we have enough capacity, we have enough servers to handle every single request we don't serve. But then we start looking around. Here, after I get my problem solved, I'm running at 80% capacity during that very small peak window. But that's important. It was worth my money. I made my money back on all the servers I spent. The money that I spent on the servers. I made it back. Now I'm at 80% on the rate. But look at all this. The rest of the year, I'm only running, because my capacity is so huge, I'm only running at 20% or less. I gotta be able to do something. with that extra capacity. Some geek comes up and says, I got an idea. Let's rent our spare CPUs. Let's rent our spare RAM. Let's rent our spare hard drive space. And cloud computing is born. How are we going to charge for it? I don't know. We can measure the amount of operations per second that a CPU does. We can measure how much data is coming in and going out. We can measure how much RAM and how much space people are taking. We'll charge them like, I don't know, 1/100th of a cent, 1,000th of a cent per operation on a CPU.
Is it like Amazon Snowball coming? Snowballs? The storage devices?
Say again, I'm sorry.
Amazon Snowballs, like the storage devices they have.
Oh, yeah, they send that off to you. That's like for their Glacier customers and stuff like that. Instead of you uploading it over the web, this is, I think, the devices you instead of uploading it all over the web, you put it on one of those devices locally because it transfers much faster, and then you ship that back and they integrate it into their cloud up there, and now you have access to it.
So,
Does that make sense?
I have a Cloud 9.
Yeah.
Cloud 9. And that Cloud 9
Probably runs on Amazon Web Services.
AWS. So there I could create like an instance. I want to choose the number of CPUs I want. So now I also have options to pay if I want more functionality. So is that kind of related to saving cost and renting their?
Ah, there you go.
So,
there you go. Now it all comes back around. Now you see. It's all coming back around on web development. So we got a guy, his name is Steve Beauregard. He's one of our graduates. And he lives on the West Coast. He owns multiple companies, so on and so forth. And he was developing a website for Honda, all right, for a release of one of their new cars. Now think about this. You and I may not be interested in Honda, but it's a pretty popular company.
Mm-hmm.
So if they're releasing a new Accord or a new lineup, their website's going to get a lot of hits whenever it's first released. So how do you deal with those hits? Well, you could go out and spend $60,000 or $70,000 on enough equipment to ensure that everybody's going to be able to view the information about that new lineup, that new car lineup. But what are you going to do with that equipment after the buzz passes, right? So, solution. We go to Amazon Web Services. We rent instances off of them. We say, let it grow to infinity because it can scale up and then it can scale back down. So as we need more processing power, Amazon Web Services dynamically adds more processing power. Need more RAM? It dynamically adds more RAM. Need more storage space in a website like that? You wouldn't need it, but if you would need it, dynamically add it. Then, as demand shrinks, I don't need those CPUs as much. I don't need as much RAM, and it shrinks back down. So now instead of spending $60,000, $70,000 on new equipment to host my website that is only going to get a lot of massive hits for 3 months, I spend $30,000, $20,000 to have it hosted for a whole year on Amazon Web Services. There is a trade-off. You have to think about it. You have to do a cost analysis and a return on your investment. Is it worth it to invest myself in a cloud-based service? Don't think about, especially in the United States and a lot of the other countries, don't think about the network infrastructure. You don't worry about that because it's pretty solid, right? It's all about, is my company large enough to be able to benefit from doing this, or should I make that initial capital and investment of $30,000 to last me 6 or 7 years? What's going to be cheaper for me? Sometimes cloud's going to be better. Sometimes it's not going to be worth it. It's going to be better to buy your own hardware. Usually the smaller companies, depending on what it is, it's better to actually buy your own hardware. But there's times it might be better to do it this way.
So one of my questions is, if Amazon has, like, they are renting their pretty much equipment and all this stuff, and we have multiple companies, like, okay, I'm going to use Amazon Web Service, So does it really slow down?
No. So now remember, now they're in the business of cloud, right?
Oh, yes.
Now they're in the business of cloud. So now they buy tractor trailer loads of hard drives, tractor trailer loads of racks. The racks come in pre-configured. They literally roll them off, roll them into the power units, plug them in, walk away, and go back and sit down at their desk and configure them however they need to be configured. Imagine this: the largest data centers are 1 million square feet.
Wow.
To put that in perspective, this building is 127,000 square feet. So it's roughly 9 of these buildings. All the floors is 127,000 square feet. So it's about 9 of these buildings, a little bit less, maybe 8 of these buildings. I don't know what the math is. 8 of these buildings filled. That means you would walk in and there would just be rows and rows and rows of storage area networks and machines. All the power running across the top. Pretty wicked?
Still, the maintenance still will be pretty high if they have all the storage devices on there.
One of those large data centers like that employs no more than like 20 or 30 people. Everything's done remotely now. That's why virtualization is so important, to understand conceptually and understand what the impact is that it's having on you. I no longer need to worry about my physical machines. I put it on somebody else. My instance is secure. Now, you have to pay for security sometimes. For example, let's say I have an instance up of a website. Amazon has multiple zones for redundancy. You have to pay for that failover redundancy, right? So if the East Coast zone goes out and you're on the East Coast zone, if you don't pay for the redundancy, you're down. But if you pay for the failover, as soon as your primary server goes down, the West Coast picks up because it has an exact duplicate, down to the second exact duplicate of whatever you're doing. It just fails over to that, picks up and keeps going. Now you don't pay double the price, but you still got to pay a premium because it's holding a spot on there. You know, that's your disaster recovery. That is your disaster recovery. And these are things you got to think about, not just with web development. You got to think about this with all things development, all things company, whenever you move into that particular area, right? When you go to your professional life, you got to take a step back and you got to start thinking about, what kind of redundancy does my company need? If they primarily just use the internet 10% of the day, do I have to have a failover? Probably not. If they use the internet 90 to 95% of the day, and the majority of that is used for legitimate business, you better have a failover network connection. Because if you don't, let's do some quick math. Let's say I got 100 employees. Right? I got 100 employees, and they make an average, you need a calculator for this, they make an average of $20 per hour. All right? 20 bucks for that. It's actually, that's probably wrong. Let's bump it up because it's a technology company, right? They make an average of $30 per hour. That's $60,000 a year, right? How much, if all 100 employees are there working that day, how much money is wasted if the internet connection is down?
So
and 100 employees, $30 an hour. So how much money per hour?
30. So it's going to be times 24.
No. The shift is only 8 hours.
Oops.
Right?
Oh my God.
You following me?
24.
All right. So give me a number.
It's going to be 30 times 8.
That's for one employee. I got 100 employees.
Times 100.
So 30 times 8 is 240. That's $240 per day per employee times 100.
240, 0, that's 240,000.
Right?
1 day.
240 times 100 is $24,000, right?
$1,000 1 day.
So because you didn't have a failover, your company just wasted $24,000 in productivity.
That's per hour.
That's per day.
Per day.
That's for one day with 100 employees working that day at an average of $30 per hour.
It could be higher than that too.
It could be. It could be. Now again, I'm putting numbers to it, but I'm trying to get you to understand the importance of conceptually understanding what's going on. Because the chances of you being in management positions and coming across some of these decisions is pretty high. You're in a graduate program. Moving into these management positions in 10 years, 15 years is pretty likely. Right?
Seriously.
And it's going to change as time goes. You don't always have to know the numbers, but you got to have some basic common sense stuff with this. Now, at the same time, let's say I have a company of 100 employees and only 10 of them use the internet that much. Then it changes the dynamics. It may not be worth it to have a failover. This campus has a failover. We have like a 4 or 5 gigabit link. If that link fails, we have a failover of a 1 gig link from another provider from another direction. It might even be less than that. It might only be like 500 megabytes or megabits. It's dramatically slower. But what happens at that point is everything else on campus will get shut down. So all the labs get shut down. Well, they don't get shut down. You can't connect. All the access points you can't connect. Dorms can't connect. Right? Only the main stuff can connect. Maybe we would have the labs, but it would be really slow. Right? Only our primary things. Our website would remain intact. You know, all that stuff. Because what are we in the business of? Recruiting students. If our website isn't there,
How do we recruit?
exactly. And it's just the environment that we live in. I want you to think about it. We live in an environment today where if a person goes to a website and it's not there, how likely are they to return?
No, they will never.
There you go.
That's
They
like-
might if somebody said, oh, you really should go back. But other than that, they're not. So you got to have that 99.999% uptime. By the way, 99.999% uptime means that during a given year, those extra nines, they're not a gimmick. During a given year, that means 15 minutes of the entire year, they might be down.
Downtime.
Yep. You add another 9, it takes it down to like 5 minutes a year. And that's why it's important to have these things in place and to understand this stuff. Especially for websites, like you said. You go there and you can't get there.
It's like buying stuff from eBay and it's not what you think.
Yeah.
I will go to that buyer again, to that seller again.
Yeah. I on eBay, man, they look even the slightest bit sketchy. I'm like, nope, no way.
They have a lot of fake items over there. Pretty much, I usually shop on Amazon.
I do a lot of that too. I'm very skeptical on eBay. The one thing I did buy, I bought an airport that I use as to stream my music off my phone.
Mm-hmm.
$20. I was like, I'll buy one of them. He had like 5 of them for sale. I was like, I'll buy one of them if it works the way it's supposed to, then you'll go back. It was $20, and now, you know, I already had 1 or 2 in place, but I wanted them in other places because I had like old speakers and stuff that people were giving me. It worked fine. Went back and bought the other 5. So I got like $500 of equipment for like, I don't know, $100. And now I got these all over the house, and I can stream my music off my iPhone and my iPad to those. I can just say, oh, I'm outside, so stream it to. Yeah, I'm with you. I'm very skeptical. Very skeptical. All right, so we're kind of over time, believe it or not. Actually, really over time. I want to introduce you to one last thing here. Can you guys still see my screen? You can't right now, right? All right, so let's do this real quick. I want to kind of get you started with VMware. Since you haven't played with it, if you play with VirtualBox, it's very similar. Let me do a little something here, and then we'll quit for the day. So if you pull up VMware, there's a couple different things. Hopefully you can pull it right up. In here, you have to change your workspace. All right. So you're going to click on Edit. You go to Preferences, and you can change your workspace from the C drive, the Documents Virtual Machines. You're going to change it to the SSD drive. You just make a new folder there called your username. Okay. Now, after you've done that, you hit OK. And now what we can do is I have some pre-built machines, and I'll show you where those are located so we can just import those. All right. So bring up a Windows Explorer. And in here under PC, you're going to see two different things. CSIT shared and CSIT fixed. Fixed is the M drive. If you go to the M drive, you might want to do this with me, Charles. You might be wanting to do it with me. So if you go to the M drive, because I don't know how you're going to remember it otherwise, here we can go to pre-built OSs, and under pre-built OSs you're going to see VMware Professional Builds, and we'll just do Windows 7. We can take and drag this down. So we'll drag this down to our desktop.
I have a quick question.
Sure.
So mine is requesting for a license key.
It'll be okay. Just ignore it for now. I'll put it back in. I'll put it in a little bit. It should give you a 30-day trial, right?
Yes.
Yeah. I'll put it in after a while. So this is local, as you can tell. It's coming down very fast. It's a multiple gigabyte image.
So I'm getting the user account control. So it's asking me for my username and password.
Oopsie.
Loading.
Hit no. Oh, here, I'll hit no. Let me try it again. I have to get that fixed. Let's see. Just crashed on mine. No, I can't do anything on yours. Let me see here. I know you can't put the key in. Just follow along with me, I'll see if I can get that fixed. Otherwise, what I'll do is have to put VMware 12 on there. It's kind of long. You can do this on your own computer too. You can download all this for free. So after you've done that, what we're going to do tomorrow, so at the very least, get this downloaded to your desktop. Oh, you can't see my screen, can you?
I have a desktop computer.
Well, that's fine, but we'll do some stuff in here too. So at the very least, get Windows 7 downloaded to your desktop from up here. And then what we're going to do is we're going to actually import that into our VMware.
It's not showing on my computer.
See now?
No.
You still not seeing my screen? Everybody, you can see it on the other computer, right?
Yes.
Yeah. So we're going to import it. Once it's downloaded, you come into Windows 7, and then you just double click on this, and it's going to pop up, and it's going to ask, what do you want to call it? We're going to call it LAMP dash WAMP, because technically it's going to be a Windows Apache MySQL install. And we'll import that, and it'll take a few minutes to import. At that point in time, we'll be able to kind of get ready and get rolling with stuff. I'll play with VMware a little bit more tomorrow with you, give you an understanding of what's going on, how to get things installed. And then for all these mini exercises, you have to set up the development environment, and you have to make a little application, right? So if we come in here and we look, I'll show you what I want. Let me see, syllabus. Sampling technology, there it is. Here it is. All right, so this is something you can mimic if you want. So on this, we just put a song in. Oops, can't spell my own last name. Click on submit. It stores it to the back end to a database. Then we're going to show all the songs in the database. So we'll do that's a select star from my table name. Selects everything, prints it out, right? And there's that last one down here at the bottom, right? Then if I want to delete something, I click on delete and I say, well, I want to delete record 35. That would be delete from, so on and so forth. And then again, back to if I want to add another song. Now, if when you're presenting this, you got to present it all. You got to present how you set everything up. You got to present your code, and you got to show the changes in your database at the same time. So as I add something to the database, you would pull up the backend database either using my PHP admin or MySQL Workbench or whatever you want to do. And you would say, look, here it is, added it in, here it is, taking it out. And that's it for the sampling technology. And that's going to be every week. That's due Saturday. But I thought I would incorporate this virtualization in. Maybe I'll help you get this environment set up tomorrow instead of a virtualized environment. You're more than welcome to bring your laptop. You can set it up on there if you want, and I'll give you a little bit of a crash course on some of this. This is the only time that I do it. The first week, I kind of help you through getting things set up and then understanding what it's about. And then after that, I'll give you resources, and it's up to you. You can ask me for help, but it's up to you to kind of figure something out. Sound good? All right. If you got, Terry, did you get this downloaded, this Windows 7 Server 2? Okay, grab that real quick. That is under, because it takes a minute or two to download.
I can't, so I was having issues with, you said you're going to help me fix this one.
Right, I got to fix that. I can't fix that right now. Right? So I can't do anything about that. So just bring up Windows Explorer and go to this PC go to CSIT fixed, M drive right here. Go to pre-built OSs, go to VMware professional builds, and then grab that and drag it to the desktop, the whole folder. There you go. Got it? Just hit no. I'll fix yours too.
So the recording, is it going to be pure audio? Or we're just going to be taking screenshots?
You're gonna use OBS. I got a lot of information up there about that. Remember I talked the other day how you need to download OBS and get all that set up and familiar with it. You're gonna do big screen capture with your audio using OBS.
I don't know if we can.
If you can do what?
Can we do it on this computer? I don't think it has audio.
You would have to bring your own microphone if you want to do it on these computers. We can walk through stuff here and then you can go home and do it.